Hello, good day viewers. Still on inequality. Already I have posted this content day before yesterday, but I realized some people didn't understand the idea or the method I have applied. So I'm here with an alternative. If you are new here, consider subscribing. Press the bell icon so that you will be notified whenever I upload a new content. And don't forget to share to your learning colleagues. Alright, let's get started. We have an inequality 1 plus x divided by 1 minus x greater than 2 minus x divided by 2 plus x. And we are looking for the range of possible values of x that can satisfy the inequality. Before we start, let us talk about domain. You should know that from the left hand side, x can never be equal to 1, because if x is 1, we have 1 minus 1, and that will be 0. And we don't want any situation that will make the denominator to be 0. In that case, we say the whole system is undefined. So x cannot be equal to 1. And you can see if x is negative 2 here, we have 2 minus 2 is 0. We don't want that situation. X cannot be equal to negative 2 as well. So let's continue. I would like to take the whole of this fraction to the left hand side. So we have 1 plus x divided by 1 minus x. As the other one crosses over, it becomes negative. 2 minus x divided by 2 plus x. We have nothing to the other side. Let us add this fraction. We can take this and multiply by this. We subtract, we take this, we multiply by this, and the denominator will be the product of this and this, right? That is how to add fractions. So we have 1 plus x multiplied by 2 plus x, then minus, we have 1 minus x multiplied by 2 minus x, divide by the product, this time this 1 minus x multiplied by 2 plus x. The whole of this will remain greater than 0. So let's simplify this and this. I think we can simplify this as x times x will give us x squared, and we have 1 times x and x times 2. 1 times x is x, 2 times x is 2x. If you add the two together, you have 3x. We have the constant 1 times 2 will give us 2. The minus, let me use bracket here, negative x times negative x will give us x squared. We have 1 times negative x, that will give us negative x. Then 2 times negative x, that is negative 2x. If you join the two together, you have negative 3x, negative 3x. Then the constant 1 times 1 is 2. 1 times 2, sorry, is 2. The whole of this should be divided by 1 minus x multiplied by 2 plus x. This will remain greater than 0. Let's continue to the other side. We have x squared plus 3x plus 2. The moment you distribute this negative sign inside, all the signs will change. This becomes negative, this becomes positive, and this becomes negative. Divide by these factors, 1 minus x, 2 plus x. It remains greater than 0. X squared will cancel x squared. 2 will cancel 2, because this is positive, the other one is negative. We have 3x, making 6x to the top. 6x. Divide by these factors, 1 minus x, 2 plus x, greater than 0. What does this mean? It means that the whole of what is on the left hand side is positive value because it is greater than 0. So on what condition will this be true? It's either if the top and the bottom are all positive, or the top is negative and the bottom is also negative. So let me write the two conditions. It's either if 6x is greater than 0, as well as these two, 1 minus x times 2 plus x greater than 0. This is the first condition. And the second condition is when 6x is less than 0, as well as 1 minus x times 2 plus x also less than 0. Remember, negative divided by negative will give us positive. So since we know that the whole of the left hand side is positive number, this is why it is greater than 0. It implies either the top and the bottom are all positive values, or they are both negative. So let us consider the first condition here. The first condition here, if we should consider this, we can use number line, right? Number line. If we assume all of these are equations instead of inequalities, you can see that by dividing both sides by 6, you see x will be 0. So we are going to indicate 0. Then if you look at the other ones, I think assuming that this is an equation, taking this to the other side, we have x equal to 1. So we have 1 here. Then taking this to the other side, we have x equal to negative 2. So let me bring negative 2 here on the number line. So we are going to test these values as well as other values in between them. And we're going to pick them here. So what happened as we choose x to be negative 2? If x is negative 2, you can see to the top we have 6 times negative 2. That will give us negative 12. So to the top we have a negative value. Negative value. And to the bottom, the moment you plug in negative 2 here, you have negative 2 plus 2 is 0. And 0 times whatever will give us what? 0. So to the bottom we are dividing by 0. And whatever we have to the top divided by 0 is undefined. So we cannot choose negative 2. Already we know that it cannot satisfy. Look at it here. We don't even have to waste our time here. Likewise 1, it cannot be equal to 1. So we have an open cycle here. So what about 0? Plug in 0 here, you have 6 times 0. To the top you have 0. To the bottom you have 1 minus 0 is 1. 2 plus 0 is 2. 1 times 2 is 2. So you can see we have 0 divided by 2. And 0 divided by 2 is still 0. And 0 is not greater than 0. Likewise, this value right here will not satisfy it. 0 will not satisfy in this inequality. So how can we do that? Let us choose a value to the left hand side, that is negative 3. And also choose a value here. We could choose negative 1. We could choose 0.1 here. We know it is greater than 0. We could choose 2 here. Okay, let's start with negative 3. Negative 3 times 6. The top will be negative 1 minus minus 3, because x is minus 3. 1 minus minus 3, that will be 1 plus 3, that is 4. Then if we have 4 here, then 2 plus minus 3, that is 2 minus 3, that will give us minus 1. And minus 1 times 4, that will be minus 4. So the bottom will be negative as well. Negative divided by negative is positive, so it's satisfied. So we can say that all values to the left hand side of negative 2 will satisfy this inequality. Let us move on to negative 1. That is a value in between negative 2 and 0. Plug in negative 1 here. To the top we have negative. To the bottom, negative 1. This is positive, right? Because 1 minus minus 1 is 1 plus 1, that is 2, positive. Then 2 minus 1 is 1 times 2 is still 2. So you see the bottom is positive. And negative divided by positive is negative, which is not greater than 0, right? So no value here will satisfy this inequality between 2 down to 0. Then we can choose a value in between 0 to 1, which we have chosen to be 0.1. So let's choose 0.1 and see what happens. 0.1 is positive, so 6 times positive is still positive. 1 is greater than 0.1. So 1 minus 0.1 is positive, multiplied by 2 plus 0.1 is still positive. Positive times positive is positive. Positive divided by positive is positive, so it will satisfy. Between 0 down to 1, we have a solution. What about to the right hand side of 1, which we have as 2? 6 times 2 is positive. 1 minus 2 is negative, times 2 plus 2 is 4, which is positive. This is negative to the bottom. To the top, we have positive divided by negative is negative, which is not greater than 0. So no value will satisfy this inequality here. So where can we find the solution? Let me conclude here. So you can see our solution is from negative infinity down to negative 2, excluding negative 2. So x value belongs to the set of values from negative infinity down to negative 2, excluding negative 2, union. Then from 0 down to 1, from 0 down to 1. So this is our solution, from negative infinity down to negative 2, excluding negative 2, and from 0 down to 1, excluding 0 and 1. So we have values in between 0 and 1. All of them, we have infinitely many of them that can satisfy this inequality. Thank you for watching. Do share to your learner colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.